Good afternoon, and thank you for joining today's virtual event, NASA and Maryland, exploring Maryland's significant contributions to NASA's mission, hosted by Senator Chris Van Hollen and NASA Administrator Jim Bridenstine. I would like to remind participants that this event is being recorded, and all participants will be muted for the duration of the event. Now I would like to introduce our host. Today, we are honored to be joined by Senator Chris Van Hollen, who represents the great state of Maryland. He is a member of the United States Senate Committee on Appropriations, where he sits on the Commerce, Justice, and Science Subcommittee, which funds NASA. And with that, I will turn it over to our host, Senator Chris Van Hollen.
Well, Damara, thank you for that introduction, and thank you to NASA for the opportunity to co-host this event, recognizing Maryland's very important contributions in better understanding our universe, our solar system, and planet Earth. Some people think of Maryland and just think of places like the NIH and the important biomedical research being done here, but we also consider ourselves a center of space activity and exploration. And we are home, of course, to NASA Goddard and over 3,300 NASA civilian employees, and they help generate 35,000 good-paying jobs in the state of Maryland that support NASA's activities. We have a robust space ecosystem, strong partnerships between government agencies, academia, business, and we really are a hub for discovery. And that's why I want to thank Administrator Bridenstine and NASA for coming together as we co-host this important event. I'm going to introduce them in a moment more fully, but before I do that, let me just do a quick sketch of some of Maryland's space assets, but also take notice of this moment that we're facing in our country with respect to COVID-19, because we, of course, have lost thousands of Marylanders and Americans. We are working hard to try to both defeat the virus and deal with the economic impact. And of course, our scientific communities have felt that impact in some cases in the spring and the summer through some delays and forced closures. But I must say that overall, I've been impressed with the resilience of all the scientists and the NASA team and others who are working their very hardest to keep moving forward on these important missions. We have in Maryland, of course, Goddard, NASA, and APL, the Advanced Physics Laboratory. We have the Space Telescope Institute. We have Wallace. We have a great university research community, and all of these organizations work very closely together toward common goals and common missions. I'm just going to touch very briefly on a few of those missions because you'll hear more about all of this as we continue through this program. But at Goddard, I've been very focused on the PACE project. It's going to advance data on our ocean health, and of course, during this time of climate change and having to deal with all the impacts from climate change, it's very important that we continue to gather that data. Preparations are underway for the 2021 launch of the James Webb Telescope, which will give us unparalleled access to previously unknown corners of our universe. The Space Telescope Science Institute is the operations center for Hubble. They have been for 3 decades, and they're getting ready to manage the science operations of James Webb, and later the follow-on launch of the Nancy Grace Roman Telescope. That telescope, of course, will revolutionize our understanding of deep space. At Johns Hopkins Applied Physics Laboratory, they're continuing work on Europa Clipper, bringing us closer to understanding if Jupiter's moon, Europa, could be suitable for life. And of course, APL is home to the Lunar Surface Innovation Consortium, bringing some of our brightest scientists together with respect to sustainable lunar exploration. You'll be hearing more about that later. Wallops, of course, while it's in Virginia, right across the Maryland-Virginia border, we have joint pride in it, and it is home to 500 Marylanders who are working at that site, and a big part of our ecosystem. Wallops is celebrating its 75th year since its first rocket launch. I believe they were scheduled to have a launch maybe even today that was postponed for weather, but I expect that's going to happen on Thursday, and we're looking forward to that. Let me just briefly mention again the very important roles of our universities and the University Space Research Association, which is headquartered in Maryland and doing important work in partnerships between NASA, University of Maryland, Baltimore County, as well as Goddard Earth Sciences Technology and Research Program in collaboration with Morgan State. Finally, I am very proud to say that Jeanette Epps, a trailblazer, who will be the first Black woman at the International Space Station, and part of that crew is a University of Maryland Terp. Let me just close by saying I'm very pleased to be on the Senate Appropriations Committee and to work with our administrator on these projects. So like he, I've had a deep interest in issues regarding science and understanding our universe. I've said to some of you before that in college there was a brief period of time when I was a physics major, but I got through quantum mechanics and bailed out. Just proof that those who can't make it through the science curriculum go into political science. But really, I still, in these often challenging times when progress on some of the issues in the Senate and House seems so slow, I do turn instinctively to the stories in the newspapers about the advances in science and understanding our universe, our solar system, and planet Earth. And that really is made possible by all of you who are gathered on this call, and of course the leading role of NASA. And I want to thank Jim Bernstein for his leadership. He did serve in Congress as well, representative from the state of Oklahoma. But I have been greatly impressed of the way he has just dived into NASA, really has a comprehensive understanding of where we need to go in the areas of space exploration and also a better understanding of our planet Earth. And so we have an opportunity to talk back and forth by phone, but also just last week in the Senate Appropriations Committee hearing, and I want to thank the administrator for his continued commitment to the decadal survey as a guide to our investments, to his support for these Maryland projects that are so important to our country's space program, and for your personal commitment to making sure that NASA is the world leader when it comes to space. So without further ado, let me turn it over to Administrator Bernstein. Administrator Bridenstine?
Oh, I'm sorry, I was muted. I want to say, Hollen, thank you so much for doing this with us from NASA. We so much appreciate your great leadership, especially when it comes to NASA's missions. You have been and you are a champion for what NASA does every day, and we thank you for the amazing support you give us. Not just serving in the Senate, but especially on the Appropriations Committee. The resources that we have to do the missions that are important, not just to this country, but to all of humanity, those resources are available because of your hard work, and we are exceptionally grateful for that. But yes, Maryland is critically important to us as an agency. You went down the list, and the Goddard Space Flight Center is, one of the crown jewels of NASA. And we think about some of the amazing work that has been done there and the amazing work yet to come. I'll tell you one of the things that has me, and we're going to hear from Dennis Andrusic here in a few minutes. Dennis is the center director there at the Goddard Space Flight Center, and he's going to have a lot to say about these missions. So I'm not going to go too deep, but I'll tell you one thing that has me the most excited, Senator Van Hollen, and that is the James Webb Space Telescope. This idea where we're going to be able to, we're talking about a telescope that is so cold, we're going to be able to pick up infrared signatures from so far deep in space that we're actually looking back in time, if you can imagine that. We're looking for infrared signatures of the very first light in the universe. In other words, we're going to be able to see with the James Webb Space Telescope what we call cosmic dawn. After the Big Bang, when first light appeared, we're going to be able to see what the universe looked like at that period of time. Now, I know you mentioned quantum mechanics and those kind of things. This idea of time and space is confounding to me. I'm not going to pretend like I can understand it, but we will in fact be looking so far into space that we're looking back into time, if you can imagine that. So I'll tell you, one of the things that James Webb is going to enable us to do is characterize a lot of the planets that we're finding around other stars right now. 10 years ago, we first started, learning about all of these planets around other stars. Now we've cataloged thousands of planets around other stars. And now we're going to be able to use the James Webb Space Telescope to really focus on those planets and make determinations as to whether or not, as the light from those stars goes to the atmospheres of those planets, we're going to be able to see that light, we can split that light into all parts of the spectrum. And we can see what parts of the light actually get through the spectrum and what parts of the light don't. And based on that, we can make assessments as to what the atmospheres of those planets are like, and not only what the composition of the atmosphere is, but from that composition, make determinations as to whether or not those planets are habitable based on what we know about life here on Earth. And we could even make assessments, if you can imagine, whether or not there is industrialization on one of those other planets. I'm not saying there is. I have no idea. But I will tell you, it really is exciting to even think about that for a period of time. And that's going to happen. We're going to be able to do those kind of activities because of the great work being done at the Goddard Space Flight Center. And, of course, I also want to mention APL, the Applied Physics Laboratory there at Johns Hopkins University. We're talking about the Parker Solar Probe. When I think about APL, one of the missions I think is the most phenomenal is the Parker Solar Probe, which is flying even as we speak. We're flying this satellite regularly into the atmosphere of the sun, into the solar corona, to make determinations as to how does the sun work, and how do we predict? Eventually, we want to be able to predict coronal mass ejections and solar flares and understand better solar wind and space weather. And the purpose for that ultimately is to protect astronauts, because we're going to the moon and we're going to Mars. And under the Artemis program, we've got to make sure that our astronauts are safe. And the biggest risk in deep space is the radiation environment. So we've got to make sure that we can protect our astronauts from those solar events that could be extremely damaging should one of them occur while our astronauts are in jeopardy, and there's ways to protect them. And that's really some of the work that we're counting on the Goddard Space Flight Center, which of course is responsible for understanding the sun through heliophysics, and then some of the partners of Goddard, to include APL, doing really amazing missions like the Parker Solar Probe. So there's so many exciting things happening. We talk about the Artemis program. We now have Hermes that's going to be on what we call the Gateway. We're building a space station that's going to be in orbit around the moon. We call it the Gateway, and the Gateway is going to have the Hermes science experiment on board, which is another way for us to understand the sun from a deep space perspective when we're at the moon. So Goddard is critical to our missions, and I know Dennis Andrusic is going to go into some of these missions more in depth. But I want to say, Senator Van Hollen, it's great to be here. I really am excited about all the things that Maryland is going to do. you mentioned the universities. We've got the University of Maryland, for example, is putting an experiment on one of our commercial lunar payload services providers. So the University of Maryland is going to launch to the surface of the moon with one of their science experiments that NASA has contracted for. Goddard is going to go to the moon with 5 separate science experiments that are going to be part of this commercial lunar payload services program. CLIPS, all of that is separate. Those are all robotic landings, separate from the human landing that we're working towards achieving as soon as 2024. So we have a really exciting agenda ahead of us. I'm going to turn to Dennis Andruzik, who is the center director at the Goddard Space Flight Center, and I want to tell you, he used to be the deputy in charge of the Science Mission Directorate here at the NASA headquarters. We love Dennis here at the NASA headquarters. He's done amazing work for the agency for many years. And when there was an opportunity to lead the Goddard Space Flight Center, he was the right guy. So, Dennis, I'll turn it over to you and let you talk about some of the great things happening in Maryland.
You bet, Jim. Thank you very much for that wonderful introduction. And it's great to see you, Senator Van Hollen. Megan, if we can bring up the first chart, that would be awesome. Here we go. That's the title sheet. You just heard from Administrator Bridenstine. I'll give a short discussion, and then I'll introduce Nikki Werkheiser, who will talk about the STMD, the Space Technology Mission Directorate Lunar Surface Innovation Consortium. Next chart, please, Megan. But to carry on with where Jim was headed, I got to tell you, I am just thrilled that Maryland is a part of the Artemis program to put the first woman and the next man on the surface of the moon in 24. And it's really important to recognize that as we put humans on the surface of the moon and then onto Mars, that we recognize that it's with science in mind, and I'm just really excited to be a part of that. And the science isn't just about humans, it's about the robotic exploration. It's about the Human Exploration Mission Directorate and the Science Mission Directorate working together with the Space Technology Mission Directorate to make these exciting missions possible. In the area of science, we want to answer really probing and important questions. We want to safeguard and improve life on Earth, obviously looking through our lens at our Earth, discovering the secrets of the universe, finding out what's happening outside of our solar system, and searching for signs of life elsewhere. Next chart, please, Megan. And if you consider the 4 science disciplines, and we heard Jim talking about some of this, and Senator Van Hollen, you were talking about some of these as well. But astrophysics, the discipline of science looking outside of our solar system, looking back in time, as Jim was discussing. Heliophysics, looking at our sun and its interaction with Earth, understanding space weather. Earth science, that safeguarding and protecting life on Earth, understanding what's happening with our Earth, the integrated atmospheres, Earth, the solid Earth, and the oceans models. Planetary science and lunar science, coming together to understand the rest of our planets in our solar system, from Mercury on out to Pluto. And I'm kind of a Pluto hugger as we talk about planetary science. But clearly the integration of those with human exploration is what the Artemis program is all about. And I've got some slides coming up on that, so I won't talk to that too much on this slide. Within Maryland, though, it's important to recognize that out of the Wallops Flight Facility, we have a full range of suborbital platforms and range services. Got a slide or two coming up on that as well, so I won't talk that too much at this time either. And Goddard has been responsible for the agency's space communication and navigation capability since NASA was first conceived. That dates back to the Apollo days. Goddard handled all the space communication capability out to the moon and back, and will continue to do that into the future. And finally, I did mention Nikki Werkheiser. We work across all technology capabilities and areas within the state of Maryland. And by the way, when I talk about these science areas, it is great to say that within the Goddard Space Flight Center and with our partners at the at APL and at the Space Telescope Science Institute, we have the largest collection of scientists in the world within the state of Maryland. Next chart, please. Now, here's just a snapshot, and I won't talk to each one of these bullets. As a matter of fact, Jim, you did an awesome job, as did, Administrator Bridenstine, you did an awesome job, as did Senator Van Hollen, in talking about some of these already. In the upper left-hand corner of this slide, you see the image of some of the images from the Lunar Reconnaissance Orbiter So when we talk about going back to the moon, I'm proud to say that when it comes to robotic science, we're already there. We've been there. And I'm excited about what's been happening. For over a decade, LRO has been orbiting the moon. The Commercial Lunar Payload Services Program, Goddard is building 5 of the CLPS payloads that will be going to the surface of the moon in the very near future. And as Jim mentioned, one of the CLPS payload is being built by the University of Maryland. And oh, by the way, I'm not an astronaut, Senator Van Hollen, but I am also a Terp. Moving around the bottom of this slide, you can see some of the future and current capabilities within the space communication and navigation. Clearly, it depends upon the RF communication, our TDRS spacecraft, working with our ground systems and near-Earth network. But also, we're at the forefront of building laser communications, optical communications. The Space Technology Mission Directorate has funded the LCRD mission, the Laser Comm Relay Demonstration mission, which is slated to launch here in the very near future on an Air Force payload, on an Air Force spacecraft in the first quarter, I think the second quarter actually, I'm sorry, Jim Ryder can correct me, of 2021. Proud to say that at Wallops, and I'll talk about the shuttle orbital capability in just a minute, here you see an image of a Minotaur launch vehicle launching the LADI spacecraft onto the surface, or not to the surface, to orbit the moon. A really, really cool mission. And we talked about heliophysics and space weather instruments. Goddard and APL in particular have been doing a whole lot in heliophysics. At the Goddard Space Flight Center, we're putting the Hermes payloads, the space weather payloads, on the gateway, as Jim discussed. That is really fantastic capability that will be synergistically working between science organizations and the human exploration. In the upper hand, you'll see that Mars instruments and Mars capability. As we think about going to the moon, and we are going to the moon, we think about what we will be doing out at Mars, and taking that capability from the moon to Mars. In the future, we'll be participating. Goddard will be participating in the Mars Sample Return mission, which will be an international collaboration to bring Mars samples back to the Earth. Next chart, please. Where we're located, and you've heard this already, but here's some images, graphical images to go along with it. At the Goddard main campus, which is about 3,000 civil servants and about 6,000 near-site contractors. That's in Greenbelt, Maryland. That's where I'm personally located right now. Out at the Wallops Flight Facility on the Eastern Shore, Dave Pierce, who is on the line and will participate in the Q&A question, he's the lead of the Wallops Flight Facility. Between Wallops civil servants, contractors, Navy personnel that are on site there, and NOAA. By the way, I don't have a separate slide on NOAA, but we do a whole heck of a lot in collaboration with NOAA in building the nation's weather satellites. But Dave houses about 1,800 total personnel at the Wallops Flight Facility. Continuing around the circle, we have the Space Telescope Science Institute, led by Ken Sembach, who is also on the phone. I've got a slide coming up on that. And we have on the phone as well Ralph Semmel, who's the head of the Applied Physics Lab in Laurel, Maryland. Next chart, please. And here's and I'm going to speak a little bit for Ken and to his horn just we at Goddard have had a fantastic and long-term relationship with the Space Telescope Science Institute. As you heard a couple of minutes ago, the Institute has been managing Hubble for 30 years now. Currently, we're doing a sim this week, as a matter of fact, for the James Webb Space Telescope, and we are working closely on what the future will look like in the Roman Space Telescope, which was WFIRST, but is now the Roman Space Telescope. We've had a long-term partnership with the Space Telescope Science Institute. Thank you, Ken, for that collaboration. And I'll tell you what, at the Institute, they take the data, they take the images, they take what comes off of the spacecraft and turn that into knowledge. And that is just a capability that is so critical to looking into the future. Next chart, please. We have Ralph on, and I'll tell you what, the work we also have going on, we collectively have going on at APL at the Applied Physics Lab is second to none as well. We heard about the Parker Solar Probe, understanding the helio environment. Parker is now orbiting the sun, and for those of you who aren't aware, the orbit of the Parker Solar Probe will slowly get closer and closer to the sun as we fly through the sun's corona, through the atmosphere of the sun, as Jim mentioned, getting down to within 4 million miles of the sun. we may think that doesn't sound very close, but I'll tell you what, it's up close and personal. 1 AU, or the distance from the Earth to the Sun, is 93 million miles. So if you think about that as 100 million miles, and equate that to a football field, the Parker Solar Probe is going to be getting down to the 4-yard line when it comes to proximity to the sun. And I'll tell you what, the science we're returning from Parker is just fantastic. The work that's going on out at APL that went on to make Parker happen is truly phenomenal. And one of their current missions is Dragonfly. You see at the center of this chart, it actually kind of looks like a dragonfly. It is I call it a quadcopter, but it's really an octocopter. You can see in that image, like a quadcopter, there's 4 motors, but there are really 8 blades helping to lift this probe from one area of the surface of Titan, which is the moon of Saturn, looking for signs of life, to another. So it's going to hop around the surface of Titan looking for signs of life. Just a fantastic mission. And these are just 2 of the many missions that APL's had going on over the years. And APL serves as a premier capability within Maryland. Next chart, please. And here's Wallops. I'm going to call this our jewel on the eastern shore. And while it was noted Wallops is in Virginia, half of the employees at Wallops work within Maryland. And they have been known for decades for suborbital missions, including sounding rockets, balloon, and aircraft measurements. Obviously, balloon and sounding rockets and aircraft are flown around the world. But out at the Wallops Flight Facility itself in Virginia, we have a large aircraft facility, which serves as a research capability. And then we have the launch range just south of the main campus on Wallops Island itself. And I'll tell you what, there's orbital launch capability in addition to the suborbital launch capability, and by way of Minotaur launch vehicles, the Rocket Lab commercial Electron launch vehicle will be going up there, and in addition, the Antares International Space Station resupply goes up from Wallops as well. We had a launch scheduled for tonight at 10:26, and due to weather, that is being postponed until Thursday night. Next chart, please. Here's just an overall portfolio of what the Goddard Space Flight Center is putting together in the next couple of years as far as launches. I won't go through each and every one of these because clearly that would take 15 minutes unto itself, which is my time allocation. But we're very proud to be working with the USGS on Landsat 9 and maintaining data continuity. We heard about the James Webb Space Telescope. Thank you, Jim. You did a great job of describing the capability of JWST and what it will bring from a science perspective. So I won't repeat that. I will only say that we're excited about the launch coming up in October of 2022. Or 2021, I'm sorry. October of 2021, next year. And our partnership with the JPSS-2 and the GOES missions are our contributions to the nation's weather satellite system in partnership with NOAA and NESDIS in particular. Next chart, please. And this is my final chart, just to give you a flavor of the capability that comes to the table. This is the sort of the demographics of the Goddard population, but I feel very comfortable that it's consistent with the APL workforce as well. And clearly out at the Institute, at the Space Telescope Science Institute, Ken's folks bring together another host of engineers and scientists. But collectively, it is a group of scientists, engineers, and technologists who are all very excited about and very dedicated to exploring space. Thank you very much. I'd like to introduce, as I said a couple of minutes ago, Nikki Werkheiser, who is the STMD Lunar Surface Innovation Consortium lead. Nikki?
Good afternoon, everyone. I hope you can hear me okay. Thank you so much, Dennis, and I'm thrilled to be here to talk to you today about the Lunar Surface Innovation Initiative and the exciting activities underway as part of that, or LSII as we affectionately call it. And we'd like to talk today about APL's leadership in executing this important work. So shortly after Artemis was announced, the LSII was established in order to ensure that we have an ambitious, cohesive, executable agency strategy for the development of the transformative technologies for lunar surface exploration. So NASA Space Tech was asked to lead the initiative to accelerate that development across the technology pipeline. Now, I'll pause here for a moment to share with you one of my favorite quotes because it really sums up what I love so much about technology development. And it's a quote from Henry Ford when he was asked about mass production of the automobile. And he said, if I had asked people what they had wanted, they would have said faster horses. So in addition to being quite amusing, it really resonates just as much today when applied to technology development. When we're trying to really create novel technology solutions, it's important that we have baked into our fundamental approach not to be overly prescriptive in our requirements, but to focus on what those end capabilities are that we need as an agency and a nation. So this is one of the key reasons why it was a fundamental tenet of the initiative from day one, that these activities be implemented through a combination of unique in-house work along with forward-leaning, robust portfolio of partnerships and collaborations. So in order to do that, we have to really assertively leverage the innovative ways that we can work together and the complementary but different strengths across government, industry, and academia if we're really serious about accelerating that needed technology development. So in order to ensure that we could both effectively execute that cohesive strategy and tap into the partnerships and the collaborations in a meaningful way, we worked with the Johns Hopkins Applied Physics Lab to establish them as both the LSI integrator and to stand up a new Lunar Surface Innovation Consortium, which you've heard referenced several times today. The consortium is a nationwide alliance of academia, industry, nonprofits, and other government agencies that also have a vested interest in establishing a sustained presence on the moon. So after looking across all of the existing university-affiliated research centers, or UARCs, it was really obvious to us that APL was the right answer. Not only does APL have a long history with complex NASA missions, as Dennis and the administrator both mentioned, but they also have an extensive and established history of developing technologies for DoD. So when you marry these two unique areas of expertise, it was obvious that APL was the perfect answer for serving as the LSI integrator and for establishing the consortium. If we go to the next slide, Megan. So over the past year or so, we have formulated that informed, ambitious, executable plan for these 6 lunar infrastructure technology areas. And if we, through LSII, can develop what I refer to as the pipes and roads for these capabilities, then we truly can reach sustainability. We can open up the commercial market on the moon and meet our national goals for successfully testing out those core capabilities that we also need for Mars. So pulling those threads, for example, you have in-situ resource utilization, or ISRU, which is how we're going to use the resources on the moon's surface to get consumables for the astronauts as well as propellants for our rockets. And then how we can use those same resources in conjunction with additive construction and excavation technologies to build structures like landing pads and possibly even habitats. Of course, we can't do any of these things without having power and the ability for energy storage. So we're developing fission surface power, regenerative fuel cells, solar arrays, and other novel technologies. And in order to do those things, you must also be able to survive the extreme environment on the moon. We have to enable rovers and manipulators and other systems to operate within the conditions of both the lunar noon, which can be up to 150 degrees C, and the night, which can go down to minus 180 degrees C, and even the permanently shadowed regions, which you're looking at minus 240 degrees C. And so now, speaking of rovers, you have to be able to access these areas. So in extreme access, we're developing small scouts and rovers that will access areas that may be too dangerous for humans, such as those permanently shadowed regions, where there's a lot of water and other resources. So even though some of these things may seem trivial at first glance, such as dealing with dust on the moon, for example, they still require new technologies. You'll notice that we don't call it dust solutions here, we call it dust mitigations, and that's because we really do have to just look at how we handle dust and mitigate that through active, passive, and operational measures. And this is an area where we learned a lot. During Apollo missions, for example, we really, of course, didn't understand the regolith or the lunar dirt properties that well. And we learned that these particles can wreak havoc on spacesuits and other equipment. So during the Apollo 17 mission, for example, crew members Jack Schmitt and Gene Cernan, they really had trouble moving their arms where the dust had gummed up the joints. And it was so abrasive that it actually wore through 3 levels of the Kevlar-like material on their boots. So you can see how each of these capability areas are critical, both individually as well as how they work together to develop an interdisciplinary ecosystem that we need for sustainable missions. Let's go to the next slide, please. So now what I'm going to talk more about, is what we're really here to talk about today, is the impactful consortium that APL has established, the Lunar Surface Innovation Consortium. And while there are a handful of research-centric lunar forums that are in existence today, this one is unique since the key focus is specifically on developing the needed technology for living and operating on the surface, and then doing that through that extensive partnering collaboration that I talked about. So this consortium provides regular stakeholder communication, networking, and it creates technology infusion opportunities, that's very important, to do this work. The APL has established the consortium and has biannual meetings as well as monthly focus groups across each of those 6 capability areas that I discussed. And that's so we can really maintain a regular, consistent interaction among stakeholders and build on that. The primary consortium objectives are to identify lunar surface technology needs, then make recommendations for addressing the gaps that are identified, and provide a central resource for gathering the information and the sharing of results. For the focus group, the key objectives are to establish strong collaborative relationships among the members, obviously, then to build that community, and very importantly, to develop the talent to execute this work. And ultimately, we want to be able to compile the member input and report the outcomes and recommendations back to that community. If anybody wants further information, we do include the website down at the bottom. We can go to the next slide. So APL held the consortium kickoff at their facility in late February. We were happy to have over 250 participants across industry, government, and academia. 52% of those attendees had not worked with NASA Space Tech previously, and that's an important metric because we also want to be able to attract non-traditional space participants, and APL is really successfully tapping into that community as well. The consortium has a strong virtual presence, thousands of online views, for example, of the kickoff. And we also announced at the consortium kickoff the new Lunar Surface Technology Research Opportunities, or LESTR as we call it, which will be annual opportunities released through the Space Tech Research Grant Program for universities to develop and mature technologies that address our high-priority lunar surface challenges. These are 2-year awards. They're valued at $1 to $2 million each. And I'm happy to say that we've just received the first round of proposals, and I'm thrilled. We've had an absolutely overwhelming response for this new opportunity. I'm also happy to share that APL is busy planning the fall meeting, which will be held from October 14th to 15th. And it'll be virtually hosted by Arizona State University. And as I mentioned earlier, they initiated the focus groups. They just initiated those in June. Between February of the kickoff and June, they established these focus groups across each of those 6 areas. And within 3 months, and I think this is very telling, within 3 months, these groups have established representation from over 160 organizations across the United States. That's even more impressive when you consider that they were able to get this established and garner this level of participation, even with the constraints of the pandemic. So I do think that's telling. If we can go to the next slide, please. So this one is just an example of the diverse representation across the entities that have joined the consortium and have regular participation in the forum. This has further convinced me, actually, that the ecosystem for these types of collaborations is alive and well, and we need to actively embrace and leverage that to develop these capabilities. We can go to the next slide. And on this slide, you can see the members of academia that are participating in the consortium currently, and APL is continuing to grow that participation. I do want to take a moment to note the importance of academia's involvement in all that we're doing. It is really imperative that they are integral to this effort. I've personally witnessed over and over again the exponential return on investment that we get when we have academic involvement from a diverse representation of universities across the nation. And we are really passionate about incorporating that into the model. APL did several assessments on the type of model to use for the execution of the consortium, and that has been a driving principle from day one. So when we do this, we really get novel ideas with hands-on participation from students, both undergrads and graduate students, as well as the professors, working on real-world challenges across multiple disciplines, and all of this within ambitious budgets and schedules. So we have found that to be a real win-win. Lastly, I'm very proud to say that within just 1 year of being established, LSI has engaged 232 organizations across 36 states to shape the technologies needed in order to establish that sustainable lunar presence and stimulate the lunar economy. Our goal, of course, is to get in all 50 states, and we're working on that. As a parting thought, I would like to note that this initiative is a nearly $250 million priority in the President's FY 2021 budget request before Congress. And as we continue to ramp up this important work and build on the promising foundation that's been established by NASA and ACL, as well as the very tangible excitement that's been generated across the nation, as you can see here, we really need to continue that level of support in this year's appropriations to meet our partners halfway and to continue building on the phenomenal momentum that has been built over the last year. So thank you again for the opportunity to speak on LSI and ACL's role in that leadership. And I'll turn it back over to the Senator for questions.
Well, thank you, Nikki, for that great presentation and all the exciting work that's going on. And thank you for leading the II effort. We're really grateful to you and your team for everything you're doing. And to Dennis and Drusik, thank you for all that you are doing at NASA Goddard. It's great to have a Turk leading the organization. And thank you also for mentioning NOAA and the work that they do in the state of Maryland for the country. And all of us have mentioned the terrific work being done by all the partner organizations in Maryland on behalf of this common endeavor to better understand our universe, our solar system, and planet Earth. And now it gives me great pleasure to introduce the heads of those organizations, including Dr. Ralph Semmel, who's the director of Johns Hopkins Applied Physics Lab, APL. Dr. Semmel, you're here, I believe. We're also going to hear from Dr. Ken Sembach, who is the director of the Space Telescope Science Institute. I want to thank him for all his leadership and the work the Institute is doing. And we're also going to hear from the terrific director of Wallops Flight Facility, David Pierce, who I just had the opportunity to speak with in the last couple weeks about what's happening there. So we're grateful for the leadership that all of you provide. And we're going to start our question and answer session now. And Dr. Semmel, if you could kick us off.
Thank you, Senator. And first, let me thank everyone for a great discussion and commitment to space. And let me thank Senator Van Hollen and Administrator Bridenstine in particular for your exceptional leadership and for participating in the event today. My first question is for both Senator Van Hollen and Administrator Bridenstine. So the pandemic has impacted productivity and resulted in increased costs and schedule delays. So maintaining planetary launch windows for science missions require additional resourcing and funding. How are Congress and NASA working together to provide the resources that these projects need while ensuring we will have a robust set of new missions?
Yeah, so that's a great question, Dr. Semmel. I'll start, and then I'll let the senator kind of share his thoughts, if that's all right. A couple of things. I think everybody understands when we think about the missions that NASA does. You know, because everything we do is a first time, never been done before kind of thing. We know there's risk in every program that we put together, and knowing that there's risk there, we always make sure that we have reserves for both schedule and, of course, funding. And we intentionally build that in based on historic models and knowing what the risks are as we go forward. What we didn't build in risk for was a pandemic. That's obviously something that we couldn't plan for, we didn't plan for. So now we're in a situation where we're using up those reserves for a good number of our missions, and that's going to present a challenge. I think it's important to note that as an agency, and I know you know this, Dr. Semmel, we've declared a number of missions essential. In other words, these are high priorities for the nation, and therefore they need to go forward even in the midst of a pandemic. Then we have some missions we identified as mission critical, which are they're not essential for the nation, but certainly they will have an impact if we don't keep them moving forward with the least amount of impact that we could otherwise have. So we've identified a number of those missions that are continuing to move forward. And because we've done that, NASA is now back. We have, maybe 70% of the NASA workforce that is working remotely, and another 30% that is back at work and moving forward with these missions. I will tell you, we've had great success continuing to move forward, but you're absolutely right. There's no doubt that we're going to have impacts to some of our missions. And so what we have to think about is, what do we start that's new, or we've got to go back to our appropriators, of which Senator Van Hollen is a great member when it comes to supporting NASA, and ask for additional resources in these future years to make sure that we don't fall further behind. So I think there's only two answers here. One is we might have to delay some missions. Two is we get additional resources. And of course, we're always looking for efficiencies, and I know you're a part of that. So those are kind of the things that we're thinking about. But I will also say, Senator Van Hollen is one of those senators who makes sure that NASA has the resources it has, and I know he works every day on that. I can give you examples. He mentioned some of them at the beginning. The PACE mission would not be funded if it were not for Senator Van Hollen. That's a critical mission for understanding how the oceans work and how it relates to carbon in the atmosphere. We think about Clario Pathfinder, which is a radiation instrument, so we can understand the radiation coming from the sun and how it gets sent back out into space, and we can measure the input and the output, make determinations as to how the Earth is warming. And that Clario Pathfinder mission would be, of course, on the International Space Station initially, but eventually prepares for free flyers to really help us get very clear understanding of how the temperature of the Earth changes. And then, of course, the WFIRST, which is now the Nancy Grace Roman Telescope. These are three missions. Were it not for Senator Van Hollen, they wouldn't be funded. So he's really done great work to help us get the resources we need for missions that are important to our country. And so I'm sure as time goes on, and as we learn more, I mean, this pandemic, we're all hoping to get a vaccine as soon as possible, but if this goes on for a long time, the impacts are going to continue to change. So we've got good assessments right now. We're sharing those assessments with the Senate, but as time goes on, those assessments are going to change, and we're just going to continue to communicate on that. So, Senator, I'll turn it over to you for your thoughts.
Well, thank you, and Dr. Semmel, thank you for the question. Thank you for your leadership, and you and I have had a chance to talk as well in the past month about what's going on at APL, and thank you for the resilience that you and your team have shown, and your ability to maintain in many of the essential programs that are going on at APL. And to Administrator Bridenstine, thank you for your continued support for the programs you just mentioned and others. Look, as the Administrator said, we're trying to work our way through this pandemic and determine exactly what the impact will be on the schedule for ongoing important programs. Of course, the web has been postponed from March to October of next year. We're working very hard to keep that on schedule. And we had a recent report from the GAO, called GAO Assessment of Major Projects, and I raised this GAO report with the Administrator in the hearing we had last week. And, one of the conclusions they reached is pretty common sense, which is that certainty in budgeting is important to be able to keep projects on schedule and funded without having to dip too far into the reserves. As the Administrator said, that's inevitable to some extent given the pandemic, but we want to make sure all these projects remain on pace, which is why, we're working on a bipartisan basis in the Congress and obviously in regular communication with Administrator Bridenstine and his team to keep all these projects that we've mentioned here on schedule and continue to be funded. I often joke with the Administrator. I recognize that he's not in charge of OMB, and we are all working together, the Administrator, the committees, and all of us to both keep all the current programs on track and accommodate new initiatives. So we look forward to continuing to work together to achieve that goal.
Good day, Senator. This is Ken Sumbach from the Space Telescope Science Institute. I'd like to thank you for your strong support of space science over the years and all that you've done for NASA and for the residents of Maryland. You and your staff have an open invitation to visit us anytime at the Space Telescope Science Institute when COVID conditions allow. Our staff have a real passion for scientific discovery, the Hubble, Webb, and the Nancy Grace Roman Space Telescope, as well as the Mikulski Archives for Space Telescopes. I'd love to talk with you about that sometime. My question for you today is as follows. It's been mentioned before here, but I'll just say again that Maryland's known for strong aerospace business partnerships that involve government, industry, academia, and small business. What will you do to help NASA capitalize on those partnerships to achieve really inspirational, ambitious objectives such as finding life on other worlds outside of our solar system?
Well, first let me say, Dr. Steinbach, we're very proud of the good work that you do at the Space Telescope Science Institute. So thank you to you and your team. I mentioned earlier that, one of the things that I always turn to first in the news is any breaking information about new scientific discoveries. And of course, my antenna went up when we heard that the biosignature discovered in Venus's atmosphere might indicate life here in the solar system and beyond. That's obviously something that you and your team and others on this call are looking at every day, those kind of new discoveries and possibilities. And your work at the Institute has been right at the center of this kind of collaborative work that we're doing in Maryland and around the country to make those kinds of discoveries. I mean, the Hubble, information from the Hubble has really brought many new revelations about our own solar system and of distant galaxies, and Webb is going to even further expand our knowledge and bring light to what has previously been invisible, and as the Administrator said at the beginning, really help us understand the early universe. And if you look at Webb, it really is an example of the partnerships here in Maryland. NASA Goddard managing the development of the observatory, the Institute managing the Science and Operations Center, and of course Northrop Grumman leading the industrial team. And as you said, Maryland has got a very advanced aerospace sector, and those private sector partners are of course a critical part of that. It's also a model and has been a model for leveraging all the different parts of our space ecosystem. And the Maryland Space Business Roundtable, I must say, is a great forum. I'm always pleased to have a chance to meet with that group and speak with the group. And I mentioned the University's Space Association. So we have a great opportunity to bring all these skill sets together to do exactly what you say, continue to expand our knowledge of the universe. So thank you for being in the middle of human enterprise.
Thank you, Senator.
Thank you. And I look forward to this.
Well, good afternoon, Senator Van Hollen. It's our pleasure to be with you this afternoon.
How are you?
Excellent. It's great to be with you. Thanks again. On behalf of all the women and men at Goddard's Walled Flight Facility, as well as our regional partners, I want to thank you and your staff for such steadfast support over these years and all that you've done for exploration and discovery and support of the Eastern Shore of Maryland and its people. So our question for you today is, the increase in telework due to the pandemic has underscored the issue of expanding broadband internet access in rural areas of Maryland and Virginia. And we were wondering, are there any new efforts underway in the Congress to help address this issue? Thank you.
Well, Director Pierce, first, thank you for your leadership. And again, it's been great to be in touch, even if it's remotely through this pandemic. And we're looking forward to the launch on Thursday. And you just put your finger on a great and important national challenge we face, which is making sure that everybody has access to high-speed internet and to broadband. And I do believe that broadband is to the 21st century what electricity was to the 20th century. We need to have universal access to high-speed internet, and right now we're of course experiencing those gaps and the digital divide in a very real way. We were experiencing them before, but the pandemic has shown a very harsh light on the digital divide. So we're focused on this in a number of areas. One is with respect to schools, because even before the pandemic hit, I've been focused on closing what we used to call the homework gap, the digital homework gap, because students who didn't have access to the internet could not complete their homework assignments, which these days require the ability to connect. That wasn't true when I was doing, my homework in middle and high school, but it is today. And of course, what we used to call the homework gap is now a full-blown learning gap for those students. So there are a number of the emergency measures in Congress right now would immediately address that learning gap for students in rural areas, suburban areas, and urban areas. Now, in terms of the lack of connection in rural areas, in addition to the Department of Agriculture that has a number of programs to expand and extend connectivity, there's also at the FCC the program, a $20 billion fund, the Rural Digital Opportunity Fund. $20 billion, as I said, this year is actually the first year that, folks can apply and providers can apply for some of those federal subsidies to expand high-speed internet access throughout Maryland and the United States. We're working on the mapping issue to really clearly identify those areas that do not have connections now, but we're continuing to push the FCC to move forward with that, as well as expanded use of what's called the E-rate program for schools during the pandemic. So we have the immediate short-term crisis of making sure every student is connected, and we also have, the need to build out our infrastructure throughout the country, and those things are moving in tandem. But thank you for asking that question. I know on the Eastern Shore of both Maryland and Virginia, this remains a big challenge, not just for students, but for businesses and everybody who really needs to be interconnected here in the 21st century.
Thank you. We have time for one more question from Dr. Simmel.
Okay, thank you. So this is for Administrator Bridenstine. So throughout NASA's history, some of the most productive periods were characterized by a strong mix of activities across human spaceflight, science, aeronautics, and technology. In the context of current and planned NASA budgets, what challenges do you see in balancing the visionary goals of Artemis with maintaining world-class space science leadership?
With Artemis, we are also funding the Science Mission Directorate, and in fact, using the Science Mission Directorate capabilities to support Artemis, and using Artemis to support the Science Mission Directorate. And there's a lot of ways that they are synergistic. But I will tell you, and I know Senator Van Hollen has heard me say this a lot, and I'll keep saying it. I do everything I can to make sure that we are attempting to follow the guidance of the decadal surveys of the National Academy of Sciences. So they put out a decadal survey for heliophysics, earth science, astrophysics, and planetary science. And as much as possible, I try to make sure that we are working towards that agenda. And sometimes, they have a bigger agenda than we have a budget. Other times, we're able to do everything, but we work really hard towards that end. We're committed to that. I am personally committed to that. Doesn't mean that we always get what we want, but we are committed to attempting. So I think that's a starting point. Then when we think about Artemis, as you said specifically, the far side of the moon. I love what Nikki was talking about with the Lunar Surface Innovation Initiative that's led by APL there. The surface of the moon is all of those mission directorate, all of those divisions of the Science Mission Directorate rolled into one. So we think about the surface of the moon, you've got subatomic charged particles that have been coming from the sun for billions of years that have been impacting the moon. And they are today right where they were billions of years ago. Other than asteroid impacts, the moon doesn't have an active geology, it doesn't have an active atmosphere, it doesn't have an active hydrosphere. So the moon is really a repository of information from the early sun. So it's about heliophysics. Of course, the best place on the planet to do heliophysics is the Goddard Space Flight Center with support from APL. So the moon is really about heliophysics. That's why when we go to the moon with Gateway, that space station that will be in orbit around the moon, we're going to have the Hermes science mission that will be a part of that, which is a heliophysics mission, a mission that's going to help us understand solar winds and the radiation of deep space, especially around the moon where our astronauts will be. But Goddard also is responsible for an architecture of communications around the moon. So when we go to the moon, we got to be able to communicate. And we want to be able to go to any part of the moon anytime we want. So we got to have a communication architecture. That communication architecture is going to be led by the Goddard Space Flight Center as well through SCAN and their programs there. So that communication architecture enables us to do other missions from the moon, like have a very low frequency wire antenna to collect very low frequencies from deep space. To do missions like the DAPPER mission, where we can collect data from not just the first light in the universe, but actually what we call the dark ages, after the Big Bang and before first light. On the far side of the moon, where it's very quiet from an electromagnetic spectrum perspective, we can get amazing science of what the universe was like even before first light appeared. Now, the challenge is, historically, that would have been a $500 million mission. But now, because we're going to have a communication architecture around the moon, we can do that same mission with a smaller payload, with less power, without having to have huge aperture antennas. We can do that mission for $90 million instead of $500 million. So in other words, because we're going to have this architecture around the moon that includes a space station, that includes a communication architecture, that includes surface activities, all of a sudden we can do astrophysics for a lot less money than we used to be able to do astrophysics for. So whether it's heliophysics, the study of the sun, or astrophysics, the study of the universe, or we think about planetary science, we're gonna be able to use the moon. Nikki talked about learning how to live and work on another world for long periods of time using all of those technologies from the Space Technology Mission Directorate, learning how to live and work on the moon using the water ice of the moon for air to breathe and water to drink and rocket fuel, using the regolith to create structures that would maybe, as she said, even include habitation. So these are exciting kind of developments, and that Lunar Surface Innovation Initiative there at APL is going to help us do those kind of things. So we think about the study of the sun, the study of the universe, the study of the planets within our own solar system, the study of the Earth. And we're learning more and more about how the moon and the Earth came into being at about the same time. They're part of the same system. Our best indicators now are that the Earth and the moon were at one time a single kind of unit that somehow separated. And so that means that by going to the moon, we can actually learn about the very early Earth, if you can imagine that. So it's about all of these different science capabilities, and the moon is the place kind of where they all come together. Maryland is going to be critical to all of it. But I think it really unites us when we talk about human exploration and science. And I think Dennis kind of put this in his PowerPoint where he talked about it's all about science. Everything that we're doing, it brings it all together in a way that is inclusive of all of the above. But again, I think going back to the premise of your question, we want to make sure that we're doing all of the missions that inform the decadal surveys, and sticking to what they have suggested. I will tell you that as we build this sustainable architecture at the moon, I think those decadal surveys over time are going to be changing to take advantage of that architecture. So I think it's a balance. It's always going to be a balance. Know that I'm committed to the Science Mission Directorate every bit as I'm committed to human exploration and the Artemis program. I know this was the last question. I probably went way too long. I apologize for that, but I think it's important to bring all of that together.
Thank you.
Well, thank you, Mr. Edgar Bridenstine, and thank all of you for joining us today. It's great to team up with NASA and the administrator to showcase Maryland's leadership in these exciting areas of space. And to all of you who are on this call, thank you for the important role you play here. And as the administrator just said, as we look at the budget, it's very important that we provide funding for these ongoing programs in the decadal survey, but also look for opportunities to expand our efforts. So we look forward to continuing to work with all of you in that regard. And I'll just close by saying, as you know, Barbara Mikulski was a great champion for NASA and Maryland's role in space policy and implementation. And when I went onto the Appropriations Committee, which I thought was very important for the state of Maryland, but also to make important national investments, I can assure you that Senator Mikulski said, now you make sure you look after NASA and Maryland's role in space. And so I've done that, not just because I'm a Maryland senator, but because of the really important role that all of your institutions play in our national strategy. And in fact, as the administrator said, really in international space policy. We are an important center when it comes to discovery and exploration, and it's great to be with all of you. And again, let me turn it back over to the administrator for his final remarks, and thank you, Jim, for the work that you're doing.
Absolutely, Senator. It's my honor. Thank you so much for joining me for this opportunity to speak to the folks in Maryland who are doing great work on behalf of NASA and on behalf of the nation. Maryland brings so many critical capabilities to the table. and we're grateful for the amazing work. It's 39,000. I think it's 39,000 employees when you look at all of the resources that NASA has in Maryland. So I just want to encourage everybody on this teleconference who's part of those missions to keep up the great work. Thank you to all of the folks that work at NASA that participated, of course, in this teleconference. And Senator Van Hollen, thank you for your leadership. And I look forward to working with you on all of the important missions that we have in front of us. And I have no doubt that we're going to continue to do great work. So what an honor. Appreciate it. And looking forward to seeing you again soon.
Likewise. Thank you.
All right. Bye, guys.
Take care.
Thank you all for joining. This concludes our event.